Warm-up number 80 reads, get a die and a coin, then toss the die and flip the coin. Do that 6 times. Make a table and record the frequencies. What were their probabilities? What kind of probability is this? So die, they're over here. If you need a coin, I have some coins right here on the desk. Come get one. And, yeah, let's get started. Go. All right, so you should have been finished with your table already. You wrote your probabilities, but what kind of probability is this? Diego. What is it? Empirical. Yeah, you have to experience it. So, agenda. Copy that. Warm-up number 80. Today we're moving on to multiplication rules. And tonight's home plate, page 222, 223, numbers 2 to 10, evens. Today's session is going to go like expeditiously. We're going to finish pretty well with good time. I'm going to give you some problems for here for class, and then I'm going to assign the home plate. Stay focused, please. So make sure you put away your AirPods. Is it loud and clear? Yeah? Yeah? All right. Send me your warm-up. There's the code. Once again, the agenda. Make sure you copy that. And code for the home plate, A9PWD. A9PWD. Those of you that are following on YouTube, you can have access to the practice there. All right. And once again, the previous home plate was page 206, 207, numbers 1 through 7 odds. And tonight's home plate, 222, 223, numbers 2 to 10 evens only. Okay? All right? So with that said, I can identify and compute basic probability. We're still in the middle of this session. We already finished the introduction. We moved on to the different types of probabilities. From there, we moved on to addition rules for probability. So today we're moving on now to a different type of probability. And here they are. We covered classical, empirical, and subjective. We talked about exclusive. We talked about mutually exclusive, not mutually exclusive. But today we're going to talk about now in regards to independent and dependent. Write this down, please. Events. Independent and dependent. Events. Independent and dependent. Independent events mean that they are events that can occur without affecting the probability of one another. So that means they are independent of one another. Once again, events that occur without affecting the probability of one another. Independent events are events that occur without affecting the probability of another. Now, I am going to give you a rule for each of these like I did last time for the mutually exclusive, non-mutually exclusive. So if independent are events that occur without affecting the probability of one another, tell your neighbor the definition for dependent. What are dependent events? All right, good. Good conversations, my goodness. Events that can occur affecting the probability of one another. Some of you are like, Mr. Q, it's Monday. No, it's not. It's Tuesday. Let's move on. Let's go. And like I said, it's going to be a fast week because we have a minimum day on Tuesday, and the rest is history from there. Wednesday, sorry, tomorrow. So once again, independent events that occur without affecting the probability of one another, events that occur affecting the probability of one another. So right now I'm going to focus on independent events. So copy this rule, please. Multiplication rule 1. When two events are independent, the probability of both occurring is P of A and B equals P of A times P of B. So write that down, please. And let me send that to your screen. There it is. And what do you guys notice on the formula? It's very similar to the one from last week. Is that correct? For addition? The only thing last week for mutually exclusive, non-mutually exclusive, it was P of A and B, and it was P of A plus P of B. Now it's multiplying both, okay? So, here goes the first example. Example 1Q. It says, a coin is flipped and a die is rolled. Find the probability of getting a head on the coin and a 4 on a die. So, copy that please on your paper so you can have this one at least as a sample for multiplication rule. It says, a coin is flipped and a die is rolled. Find the probability of getting a head and on the coin and a 4 on the die. Now, just FYI, guys, once again, reminder, any late assignments, I'm giving you at least half. I'm being gracious like that. But once we finish the third quarter, I'm no longer going to accept any late work. So make sure you stay on top of your assignments, because fourth quarter is just like so that there's no pressure on you or me, and it's just to cruise and finish up our course expeditiously. So make sure you're on top of your stuff. Please. My goodness. Once again, a coin is flipped and a die is rolled. Find the probability of getting a head and the coin on the coin and the 4 on the die. So, here we go. First things first, we write our formula. P of A and B, same as P of A, times P of B. So, first things first, tell your neighbor what A is and what B is. What is A and what is B? Turn over to your neighbor, let them know what A is and what B is. All right, good communication. Diego, go. What is A? And B? That is correct. So this is P of heads and P of 4. So this is P of heads times P of 4. So, enlighten us. Tell your neighbor what is the probability of heads and what is the probability of rolling a 4. And then Diego will pass it to someone. All right, good communication. Diego, go. Joseph, P of heads. And P of 4. Therefore, the probability of both happening is 1/12. From 1 to 5, I'll come to Barry with this. We got this, right? Yeah, 5s. All right. Send me your notes, please. I want to see what you're doing. All right. So, they're both independent. One doesn't affect the other. That's why we have each one its own probability. That's why P of H is 1/2. P of 4 is 1 out of 6. All right. So let's go to example Super Q. It reads, a card is drawn from a deck and replaced. Then a second card is drawn. Find the probability of getting a queen and then an ace. Write that down, please, as well. Write the words. You don't have to copy all these. I left them here so we can use them as a reference. A card is drawn from a deck and replaced. Make sure you write the words down because this is very imperative for the next rule that's coming. A card is drawn from a deck and replaced. Then a second card is drawn. Find the probability of getting a queen, then an ace. All right, so once again, a card is drawn from a deck and replaced. What does that mean, Mr. Q? That they draw a card out, and then they put it back in the deck. So that means everything stays intact. Then a second card is drawn. Find the probability of getting a queen, then an ace. Therefore, first things first, our formula, yes? So, Joseph, pass someone so they can guide us through this. Peyton, go. All right. So what is A? Peyton. The queen is A. Okay. So therefore we write P of queen and ace. Okay. Which means P of queen times P of ace. So tell your neighbor the probability of drawing a queen, then the probability of drawing an ace, and then Peyton's going to pass it to someone. All right, good. Peyton, pass someone. Mia, probability of drawing a queen. And here are the cards so you can see them. 4 out of 52 times, how about drawing an ace? Hands, if you agree with that, that is correct. So 4 times 4 is 16. 52 times 52, let's see, calculators. 52 times 52. Daisy, what'd you get? 2,704, and if we simplify this, that means if we divide by 16 top and bottom, should be 1 over 169. From 1 to 5, how comfortable are you with this? Yeah, we got it, right? Yes, Mr. Q, give us more. All right. All right, send me your notes, please. Come on, people, wake up, my goodness. Ah. So far so good. So one thing to note, look up, please. It said here on this one, a card is drawn from the deck, but then replace. Remind your neighbor what replace mean. What does replace mean? What does replace mean, Fernando? What's that? Put the card back with a C. There it is. Back in the deck. That's what it means. Okay. All right, let's go to the next one. Look up. It reads, a bowl contains two, oh my goodness. A bowl contains 2 red balls, 3 blue balls, and 5 white balls. A ball is selected and its color noted. Okay, so selected, noted. Then it's replaced. That means it's put what? Back in the bowl. A second ball is selected and its color noted. Find those probabilities, A, B, and C. So on your paper, just write example mega Q, A, B, and C, and just go with the formula and start from there. Let's see how you do with those. I'll give you some time. And all right, Mia Victoria, pass them one. Chelsea, bah! What is A? And right now we're working on part A for this one. What is A? Close. You can't get 2 of them out. We start with first, look at the instructions. A ball is selected, it's color noted, and then another one is selected and it's color noted. So what would be A? Red. And how about B? Very good, red. Yeah. Yes? So therefore, formula would be P of R and R, which means P of R times P of R. So what is that probability for each of those? Tell your neighbor, and then Chelsea's going to pass it to someone. We had 2 red, 3 blue, and 5 white. All right, pass someone. Chelsea. Daisy, probability of red. 1 out of 10. Close. Tell your neighbor once again how close she is. All right, let's see. Let's try it again, Daisy. 2 out of 10. That is correct. 2 out of 10 times 2 out of 10. Therefore, this is 4 out of 100. Simplified, that's what? 1 out of 25. That is correct. Hands if you got that by yourself. All right, good. So, work on these next, and I'm going to send you this. Oh, you already have the screen in front of you, so you can send me your work as soon as you're done. 30 seconds. Go. All right, for the sake of time, B should be P of B for blue times P of W. Is that correct? Therefore, who went last? Daisy, pass someone? You can pass it back to Peyton, sorry, if you want. Who, Daisy? Chelsea, what is P of blue? Very good. 3 out of 10, because there's 3 blue balls out of the 10, times, what is probability of white? 5 out of 10. Therefore, this is 15 out of 100. Simplify that. That gives us what? 3 out of 20. Hands, if you got that? All right. And so on and so forth. So, from 1 to 5, how comfortable are you with independent events formula? Good? All right. So send me that, and let's go to the next one. We're moving on to dependent events. Dependent events. Copy this formula. P of A and B equals P of A times P of B dependent and of A. So let me pause the tunes in the back. Let me read this again for those of you that missed it. Here it goes. Look up to the screen. This reads P of A and B is equal to P of A times P of B dependent of A. It doesn't mean P of B divided by A. No, it means B dependent of A. You're like, So make sure for this bar right here, you understand that it's dependent. Dependent. That's what it means. B dependent of A. All right? Let me zoom out. All right, so P of A and B is the same as P of A times P of B dependent on A. You're like, what does that mean, Mr. Q? That now we need to look at the previous one to write our probability of the new one, because it's dependent on what happened before. Okay? So once again, when 2 events are dependent, the probability of both occurring is P of A and B equals P of A times P of B dependent on A. Okay? So I'm going to leave that on your screen, and I'm going to move on mine. Here it goes. And it reads, look up to the screen. 3 cards are drawn from an ordinary deck and not replaced. Find the probability of these events. Okay, so before I move on, look up. Tell your neighbor what was the difference between the previous examples to this new example. Tell your neighbor the difference. What's the difference? Look at the instructions. Don't have Chelsea pass it, or who went? Chelsea? Oh, she'll pass it to someone. 3 cards are drawn from an ordinary deck and not replaced. So, Chelsea, pass someone. Peyton, what's the difference from the previous examples to this one? Yeah, they were replaced on the last one. They were put back. On this one, they're not put back. So when you take something out, that's going to create something different. That's why it's dependent on what you do before. So let's start with getting jacks. Ready? Let's do A together. On your paper, write example 2Q, A. So we have P of A and B is the same as P of A times P of B dependent on A. So I'm going to go, at this time, we already know that it's P of J, right? P of jacks, right? All right, so it says getting 3 jacks. So let's start with 1 jack. What is the probability of getting 1 jack? So we can start P of A. Pass on one, Peyton. Probability of getting 1 jack. What is it? Okay, I'll pick. Peyton, go. They're right there. 4 out of what? 4 out of 52. Write that down. Times. Okay. So that's 1 card drawn, right? How many times are we going to draw a card? How many? 3. So check this out. We took a card. We didn't put it back. All right. Tell your neighbor what would be the probability for the next jack. Let's see if they have it. Think about it. Now replace. What would be the probability of the next one? Probability of the next one. Probability of the next jack. And then a 3rd jack. Talk it over to your neighbor. I'll give you some time. Digest that. This is the last example that we're doing. B. Peyton, pass them one. Daisy, what would be the next probability? 3 out of 50 what? Hands if you got that. That is correct because it was dependent on what happened before. What happened before? We took 1 card out and left it out. So now we only have how many? Probability of 3 out of 51. Therefore, 1 more probability. Pass them one, Daisy. 2 out of 50. That is correct. Therefore, 4 times 3 times 2, that is 24 out of 52 times 51 times 50. Mia, pass someone. Dylan, 52 times 51 times 50. All right. And can we reduce? Let's see, 12, that's 600? Dylan? 135, 200 divided by 2? 67,600. And again, divide by 2. Yes? Okay. Where did I go wrong? What? 100, thank you. 132,000 what? 600. So then half of that is 6,600, 300, 66,300. And reduce. Anyways, from 1 to 5, how comfortable are you with dependent events? Dependent. 5. All right, so before we move on, though, because these are just practice problems that will be very similar. Once again, tell your neighbor the difference between independent events. What was the major difference from independent events to dependent events? What is the one thing that you notice? All right. Communication. Send me your notes, and I'm going to send you the assignment for this class that's due at the end of the period, numbers 1 through 9. There's numbers 1 through 7, odds, and then I'll post the other two as soon as I see that you're almost done with that. And it's already open on Canvas, so make sure you take a picture and turn it in on Canvas. Yes? I'm sorry? No, the even's for your home plate. Odds is for right here, so you can get practice. That's why I was having you guys communicate with each other, so you can help each other. My goodness! Bah! And for those that are following, I'm going to stop right there, or actually, I'll come right back so I can post the other 3 problems that are following. 1A states, state which events are independent and which are independent. My bad. Which are independent and which are dependent. So look at A, tossing a coin and drawing a card. Okay? So tell your neighbor what that would be. Independent or dependent. And who went last? Dylan? Pass someone, Dylan? Jaden M. What is A? Tossing a coin and getting the card. Does one affect the other if you write it out? Independent. Hands, have you chose independent? That is correct because it doesn't affect the outcome from one to the other. Let's go to B. Drawing a ball from an urn, not replacing it, and then drawing a second ball. Pass on, Jaden. David? One B. Yeah. Dependent. Hands, if you agree with that? Yeah, because it wasn't replaced, right? So the probability of the second one depends on the first one and so on and so forth. All right? And that's all you do. You write it out, move to the next one, number 3, number 5, number 7, and I'll give you guys a little bit of time for that, and I'll post the other one. For those of you that are almost done, I'm posting number 9 over here. There it is. And I'll stop the video right here for those that are following along on YouTube. And remember, the evens are for extra practice. And for my students, the evens are your home play. Let's go. All right. Later. Bye.